Okay, last time we started chapter number 1, and chapter number 1 is related to the physical quantities and the measurement, and we discuss about we already know about base quantities and the drive quantities, so we skip that part and we started with the concept of the errors. Then we start the concept of uncertainty, and in uncertainty there are different types, and we need to discuss three types: the absolute, fractional, and the percentage. So absolute is very straightforward, like the addition of the errors, and simply we can solve with the other formations of the any type of question is given there over there, so we can easily find out by adding the values. And let's suppose if we need to find out the divisions, because we know that errors can never be divide or never be can be subtracted like that, because we know that if error is in the initial stage, so it will carry on, so that's why errors can be added. Okay,
Okay.
so that's why we used to take the percentage, right? Whenever we perform the practical in lab, so always there is a section at the last of the experiment for the percentage error. So we used to calculate the percentage error. So that is the main concept, right? And we also solve one question related to that, that if two quantities are dividing actually, so we can just find out their values by calculating their individual percentage error, and then we place in the division formula, then we divide their percentage error, right? Not their actual values. Okay, and we found out we find the value that is 10%, 20%. That means the 20% is the error in the final value. So we just multiply that 20% with the actual value, so that will give you 0.3. So 1.3 plus minus 0.3 is the final answer for the quantity that we were calculating last time. Okay,
Okay.
and let's suppose if we continue from this part, and they ask you about, like there is another part of this question, and in that part they ask about find absolute uncertainty. So let's suppose if they ask in you in the question that values are given, and they just simply ask that find the absolute uncertainty for the given values or for the given question. So you need to perform till this experiment or till this step. So you need to solve all the steps till now, and this final value actually shows you the absolute uncertainty, right? Because you can see that your value is written in the form of plus and minus, and we know that in absolute uncertainty, that is the first category. So addition, subtractions, in that form, if we write the value, so the values written in the addition or subtraction form gives you the concept of absolute uncertainty. So if they ask about absolute uncertainty, so don't get confused, you need to perform the same procedure, that calculate the percentage error and then solve according to the procedure of the percentage of each and individual quantity, and finally just write in the form of addition and subtraction, right? So that is the absolute uncertainty concept. Okay,
Okay.
and let's suppose if we consider another example of multiplication. So we know that the concept of multiplication is also not simply applied on the errors, right? Because errors can be added, right? One by one, it is going to be added. It is not going to be multiplied, right? Let's suppose if you make three errors or three mistakes in your experiment, so that will be added one by one. It will be not like that three of them multiply with the initial error that you made, because error depends upon the situation, that how much error you made over there. It is not like that always there will be a same error every time. Okay, so that's why the
O-
multiplication of error is also not possible. Okay,
all right.
Okay, now let's suppose if we are having new values, or values may be anything, because first of all we need to know about the concept, then we are able to solve the question. Because this uncertainty is going to be added in your A2 also in P5, and there is a complete table and you need to fill with the uncertainties.
Wait,
So
is
there,
the also in P3?
yes, in experiment paper it will also help you, because this is
So it's
particularly
only
related.
P5 both. But it's not going to be in like P1, P2, P4.
It will be like in theory section also, but the values will be not like this, because we are writing very simple values, right? I will also show the question, that how questions are going to be included
Okay.
from chapter 1, right? So we will solve this question also, because in this all values are given, but they give you reference of some concept, like in this we are having a concept of upthrust and terminal velocity, like that. Okay.
Okay.
So the value of B is 2.0 plus minus 0.2, and the requirement of the question is to find, let's suppose, an unknown quantity which is equals to A cross B, that is the multiplication of two vectors, right? So again, we know that we are not going to multiply the errors, right? Actual values can be multiplied, like 2 multiplied by 1 can be possible, because those are simple numbers. But after plus minus, we are having their uncertainties values, like their errors. So we are not going to multiply those errors, right? So initially we start with the first step, and your first step will be 1.0 multiplied by 2.0, right?
Mhm.
So this is the multiplication of the numbers only, or the actual values only, right? But now when we are going towards the errors, so we are not going to perform like this. We have to calculate again the percentage error, right?
Yeah.
And then we just finally add them, because we need to find out the absolute uncertainty. So again, we are going to follow this theme, that percentage error in D will be equals to percentage error in A plus percentage error in B. Okay. So again, we need to calculate the percentage error in A, percentage error in B, and then we need to find out the sum of their total error. And then finally, we include that value with the original value 2.0. If we just quickly calculate the percentage error in A, so what will be the value?
So, wait, how?
Okay, so that is the confusion sometimes, because all numbers are like same. So sometimes we got confused. So actually, we got percentage error. We are going to calculate the percentage error of A. So we only focus on A. So basically, there is an error of 0.1. Okay.
So they're like the minimum, what the minimum value can be 0.9 and the maximum is 1.1.
Actually, your total, yes, it will be 0.9 till 1.1. Okay. So now you need to
Yeah.
find out that how much uncertain you are about this value. So basically that is 0.1. So what we need to do, we just write the error in the numerator and divided by the actual value, that is 1.0, multiply by 100. Okay.
Okay.
So that will give you 10 percentage. So it means there is 10% error. Okay. If we take the value of
Okay.
1.0, and same goes for the B. So for B, we are going to use the same thing, 0.2 divided by 2.0 multiply by 100. So again, you will get the same 10% error, right?
Yeah.
So percentage error of A and B is calculated over there. Now what we need to do, we need to add them according to this equation. So according to this equation, the total percentage error will be 20%, right? And
Okay.
again, final thing, we need to find out the absolute uncertainty, right? Because mostly
Yeah.
our question ends up with the absolute uncertainty, because our original question is also in the form of absolute uncertainty. So what we need to
Okay.
do, we got a 20% the error, and what is the actual value of D? That is 2, right? The original value without errors. So we need to multiply. So absolute value of D will be equals to 20% of 2.0, right?
Okay.
So you will get 2 to the 4, that will be 0.4, right?
Yep.
So final answer will be equals to 2.0 plus minus zero point 0.4. This is the absolute uncertainty of your value D. Okay. So
Okay.
most of the time we are going to follow this procedure, because normally this is the only thing that is left behind, because we know that we are not going to divide the errors, we are not going to multiply the errors. So that's why we are going to calculate the percentage of the errors, right?
Right.
Okay. Now, one more important thing related to the uncertainties.
Okay.
The first one is, you observe in all the values that we always used to write 3.0, 2.0. We never used to write like 0.13 or 2.46 like this, right? So there is a reason
Yeah.
behind that. The reason is that your absolute error must be in one significant figure,
Oh, okay.
because 0.2 means only 2 after decimal point is the significant, right? The 0 before decimal is not significant, right?
Yeah.
So the absolute error must be in one significant. And the next thing is, you need to also follow that decimal point, right? Try to mark the decimal point uh, in the same place as the all other value, or because we are calculating the value of D is not given in the question, A and B is given in the question, but we need to follow the same decimal point, right? And just
Yeah.
like the values given in the question, so match decimal places in values. Okay, so these two things are important while writing the final answer, because sometimes we calculate the value very accurately, but there is a problem in writing the significant figure, so that will deduct our marks. So that is important to remember, that always absolute error must be in one significant figure, right?
Okay. Let me write that down. So we have to match the decimal places?
Yes, because now for the time being, we are just taking the values very simple. But in question, sometimes if like we take the value of G as 9.81, so there will be a different number of significant figures. So we will also discuss that how to match the values, how to match the decimal places in your final answer, right?
Yep.
Okay. Let's suppose if we want to solve the same concept in the form of powers. So if we talk about with the reference of powers, right? Because we are only talking about the normal values. But let's suppose if we want to solve with the reference of power, so how we are going to solve that one, right? So let's suppose if we are having a value A is equals to 2.0 plus minus 0.2, and we need to find the value of E, which is actually equals to 4A square, right? So now we are having a question in power. So we know that 4 is actually multiplying with A, and we know that we are not able to find out the errors in multiplication form because error cannot be multiplied. So that is the concept. So what we need to do, we first need to split this one like this. Actually, question is in simple form is this 4 multiplied by A multiplied by A. Now, I hope you got the rest of the thing that what we need to do. We first need to find out the actual value of E, right? And how we find that? What is the actual value of A?
For A, it's gonna be
2.0, right?
yeah. Aren't
And
we
we need to
supposed to like
square. Yes.
okay. Because that's the formula?
Yes, because that is the given situation, right?
Okay.
Because you
So
can
like
see,
whatever they tell us what the situation
yes,
is, we like adjust ourselves for
yes.
that.
Yes, because A is the value. A might be anything. Let's suppose A is acceleration, let's suppose, and E is unknown quantity and a new quantity which is equals to 4 times of acceleration square, let's suppose. So we know that the
Okay.
value of A is already given. So we need to substitute that value in your equation. So that will be 2 square. So finally you got the answer 16, right? Okay. So that is the situation. We got the original value of E. Now the rest of the thing, that we need to find out the percentage error again. And in this situation, we are having only a one value A. So we only need to calculate percentage error once in this question.
We're gonna do 0.2 divided by 2 multiplied by 100 and that will give us
Yes.
10%.
Yes. So your answer will be again 10%.
10%. Is
And one
okay,
more
and
thing.
then we know that E is 16 and then
Hmm?
E percentage is it gonna be
Yes.
are we gonna like do like 10% multiplied by like 16?
Okay. Actually, we are going to multiply that 10% with 16, but there is a problem in the question is that they mention A square, right? We only calculate value for A, and we are not going
Yeah,
to square that one because that will be equals to 100 percentage, right? It means 100%
yeah.
error. So that's why I split the question. So in simple form, the question is actually this. We know if we calculate the percentage error of A, so that will be same for the second A, right? So it means percentage error of E will be equal to percentage error of A plus percentage error of A again, right? Because we know that there are two A in multiplication form, but we know we are not going to multiply the errors. So that's why we are adding their percentage errors, right?
Yeah.
20%, right? So
Okay.
finally, again, the step you mentioned that now we need to multiply with the original value. That is the absolute uncertainty. 20% multiplied by 16. That will be 3.2. Okay.
Okay.
And then just you need to find out the final answer with the help of these errors, right? We will apply this concept on the practical questions also.
Wait, so the reason we did percentage E equals percentage A plus percentage A is
Hmm.
because we only have one value. It's not like we have A and B, so and then they
Yes,
told us square, so we're gonna use like percentage
yes,
A plus percentage A
yes.
as total.
If we just replace A with B, so again the question remains same, 4AB. So basically we are doing the same thing, 4AB, or we are having same variable, so 4A multiplied by A, right?
Okay. And
So
the
in
final answer is gonna be 16 plus minus 3.2.
yes,
Okay, I think I get it. The solving
okay.
part.
Uh, Slightly it will be a difficult one, but just always remember one thing:
Okay.
whenever you find question of division, multiplication, just what you need to do, we need to split the question in simple form for yourself. Sometime it will be in a very simple form already there, so you don't need to do like that. And then just find out the percentage error of individual quantity given in the question and then add them, right?
You're right.
Okay. सो बेसिकली नॉर्मली जिस तरह हम कहते हैं कि जो हमारी अच्छाइयाँ और बुराइयाँ वो एक एक करके ऐड हो रही हैं, सो इन द सेम वे all the errors are going to be add, not multiply, right?
Okay.
So this is the concept of the uncertainties in and the errors. Because in normal question, when we do the question of forces, so somewhere randomly you find your answer with absolute uncertainty, so then you need to adjust your answer according to your error. We will find that question also in the past papers during the practice. So let's suppose if we consider, okay, let's suppose if we consider this question, because first chapter is not only related to uncertainties, it is also related to the quantities. So let's try to solve the first question. So a sphere of radius 2.1 millimeter falls with terminal constant velocity through a liquid as shown in figure, and the radius is 2.1, weight is given, and three forces act on the moving sphere: the weight of the sphere, the upthrust, the viscous force, right? And viscous force is unknown basically. We know two forces, but the third one is missing, right? And they already gave you the complete equation, right? It means that is related to your first chapter, because they are only asking about the quantities, right? Not to find out any specific value. Now let's see what they are asking. R is the radius, okay? So we know about R. R is radius, V is velocity, and K is, the value of K in SI unit is 17, right? So they just give you the value 17. might be we use this value in other part of this question. In first part, they are
Mhm.
asking determine the SI base unit of K.
So K is constant. So when radius, um,
Okay, first of all, we just arrange the equation like this. K is actually equals to
F
viscous
divided
force
by R.
RV. Okay. Now
So
the
where
question is
F
very simple.
is the force. So
Yes.
force divided. Okay. So force is newtons.
And in simple,
Uh,
if we split Newton, so Newton is further split into
mm,
kg meter per second square. If you find it
yeah,
difficult, so you may just compare it with F equals to ma
yeah. So it's gonna be kg multi
meter per second
kg
square.
meter per second square, and then divided by radius is gonna be in meters, and the velocity is also gonna be in
Yes.
second meter per
Kg.
second, right?
Yes. Kg meter per second square divided by,
So the meter cancel out, right?
yes.
And then also one of the s cancels out, so the what you're gonna be left is kg, uh, and then kg per second. Wait. No, it's gonna be kg per meter second.
Okay, so for R, we are having radius, so we know radius will be equals to
Yeah. And then velocity is always meter per second.
meter per second.
So it's gonna be m squared divided by s, right? Like m
Yeah.
squared and then s minus 1.
So m is simply cancelled out over there, right?
Yeah. And then
Uh,
one of the s is also canceled out at the top. And the one bottom is also canceled out. It's gonna be kg s minus 1 divided by m.
okay. So finally, we can write it as kg per meter, right? Because now meter is only left in the denominator, so that will be -1. And finally, -2. And if we shift the value of s minus 1 in numerator, so how we are going to write that one? It will be -1 or -3. The final answer for second.
Is it gonna be minus because
Yes,
when you
it
like
will be like this.
-1.
Yes, because when quantities
Yeah,
are in divide, so we just subtract the powers, right?
yeah.
So that will be minus minus plus. Okay,
Okay, so it's gonna be minus 2
-1.
plus 1, so it's gonna be minus
Yes,
1.
-1. So final answer is
What is it measuring though, this kg meter minus 1 second
this
minus
is actually equals to your viscous force, right?
okay.
Because they mention in the question, right?
Mm.
Okay. Uh,
So
Walaikum assalam. So we solved the first part, right? And that was the simple one because that is related to the quantities. So we already know about the quantities, so that will be not much very difficult to identify the final answer. And
yes.
let's suppose if we further go with the next part. So let's see what they are asking. Okay, now they are asking that using the value of the thrust, upthrust acting on the sphere to calculate the density of the liquid. So value of upthrust to calculate density. So let's see where the value of upthrust. Upthrust is, yes, this is upthrust. 4.8 exponent minus 4. This is the value of upthrust. And what you need to find out? You need to find out the density of the liquid. So for this, we need to study about the upthrust concept, right? So just leave this part because this contains the formula, right? When we studied the topic of forces. So when then we are able to understand that thing, right? For the time being, I just only write the formula and you are just in confusion that is this formula is included in chapter 1 or not. Okay. So we just skip this part for right now. And let's see if the last part is related to your chapter 1 or not.
Okay.
Determine the magnitude. Okay, so that is also related to the terminal velocity. So it means that only first part is related to our first chapter in this paper, and rest of the part is related to your motion and forces, right?
Okay.
Let's check another paper because you can see that topic is very much basic as compared to the other topics, and that is mostly includes the same concept that you already know about it. So if we talk
Yeah.
about another paper, okay, paper is blocked. Okay, this is the paper. Yes, this is related to uncertainty. Okay, sometimes you can see that for 1 mark they just used to ask the definition sometimes, because in the final exam we have to know about all the procedure, all the topic. So that's why they may ask anything anywhere, but we know the basics. State what is meant by the work done. So we already discussed that concept in IGCSE, that is the product of the force and the displacement. Or we can say that when force is applied on the object, so object will displace in the same direction, right?
Yep.
So I'm writing in the short for the timing because that is the basic thing you already know. Next, they are asking use the answer to determine the SI base unit of power. Okay. So
Okay.
basically, what is the concept or of the power? Power is equal.
Work done. Work done.
Hmm,
Wait, so I have to use the answer to A to determine the SI base unit of power.
yes. So
So
basically,
power equals to the work done in how much time?
okay, W
So
over T.
yeah,
Next,
so it's
yes,
gonna
you
be
may carry
measured in
on.
watts, right? So it's
Okay,
gonna and watts is basically the work done, which is joules, or like F
okay,
times D is gonna be
hmm,
Newton meters per second.
okay, good. Okay, a simple thing. You can just go from the SI unit to SI unit, or you may just go from the quantities, the formula first, then we just use the SI unit. Like we use the concept because they mention use the answer to A to determine. So W is equals to FD. So we may also consider this formula like this, FD over T. Okay.
Okay, so this is like a derived unit.
Yes. So basically this is the drive unit, and then we are again coming towards the basics. Okay. So now you are able to write the SI units, and we know the SI units of force and all the thing. This is for force. This is for displacement, and time is equals to seconds, right? So your final answer for this power will be equals to kg meter square per second cube, right? Because the s in the denominator will also be added with the minus power. So that will be equals to -3. Okay.
Okay.
So this is the first part, and the second part of the question. Okay, so now we are having some percentages over here. So let's see. So we are having a equation, right? Output power. Output power is equals to V cube B. V is maximum speed, B is constant value, okay, for the car. So now you can see there is a power in the question, right? So the last part that we discussed. So power is actually equals to 84 kilowatt plus minus 5% of error, and B is 0.56 plus minus 7 percentage in SI unit. Okay. So basically we need to calculate the value of V. So first of all, we just simply follow the procedure from the formula. P is equals to V cube B. So we need to find out the V. So V cube will be
Okay.
equals to straightforward and the cube root also. So we are taking cube root of P over B, and values of P and B are given. So what we need to do, first of all, they are only asking about to calculate the value of V. So when they are asking about the question in linear form, so always solve in the linear. So it is not compulsory to add the percentage in the normal values, right? So for this, what we need to do, we take the cube root. P is equals to 84,000 or 84 into 10 to the power 3 divided by 0.56. So first calculate the answer of this value.
Okay. So what am I doing? I don't have my calculator right now.
Okay. So actually your final value will be equals to 53 meter per second, right?
Okay.
So this is the final answer of V, and that is not a difficult part, right? The only thing is to discuss in
It's
this
just
chapter
like
is,
change.
yes, your
Okay, it's
formula are
easy.
already there. So we don't need to think about the theoretical concept, right? In this type of
Okay.
question.
Also, in this chapter, are we gonna like cover conversions, like the different?
Conversions is the same part for just like the IGCSE. So if you want to discuss about the conversion, so I will also discuss the conversion if you have some confusion in that.
No, I don't. But it's just like, is it just the main like? Is it from giga till nano, or is there more?
No, no. Normally we just follow till nano. That was also
Okay.
be used in only wave section because in waves we used to write the values in nano. Otherwise in normal we just follow mega, micro, milli, only that thing, right? That it
Okay.
topic is included also in CRO. We find that micro, milli was there, not other prefixes was there, right?
Yeah.
Now this is the main part, the uncertainty or the absolute uncertainty, because they always ask about absolute uncertainty, right? Because they want answer in plus minus form, so that's why they used to ask about uncertainty, right?
Okay.
So actually what we need to do, we need to find this one, right? But the problem is that we are having a cube root, okay? So cube root means whenever we are going to solve like this situation, because cube root is a different situation from square and cube. So basically it will be equal to 1 over 3, right? Because if there is a square, so what we do, we just multiply two times. If there is a cube root or a square root, so we need to divide that value, right? If there is a square root, so we write 1 over 2. If there is a cube root, so we write 1 over 3. Okay, clear?
Okay.
So now what are their percentage error? The first one is 5% and then 7%. So again, we know that both are dividing or both values are divided by each other. So we are not going to divide. What we need to do? 5% error plus 7% error, right?
Yeah. Okay. But where did the 1/3 come from?
Actually, this 1/3 is due to the cube root, right? Because the value of cube
Oh, okay.
1/3.
Yeah, yeah, okay, because V is
Yes.
equal, it's a V cubed, so you're like,
Yes. So we just simply use this for formation. We don't need to start from the scratch because previously we do all the calculation. So in this
yeah, okay.
question, yes, we already have the percentage error given in the question. So that will save your time in calculating the value. So we need to add 5% plus 7% divided by 3. So that will be equals to 12 divided by 3, right? So that will be 4%. So actually there is a error of 4% in your total value, right? So what we need to do to find out the final answer for the absolute uncertainty, what we need to do, we know there is an error of 4%, right? By using this equation, yes, we need to divide the error by the original value multiplied by the 100. Okay,
Okay.
this is percentage right now. This is not the absolute right now. So that will be equals to the change in your volume or the velocity divided by the actual value multiplied by 100. And your value of V is,
V is 53.
actually we shift this value like this because we need to find delta V.
Yeah.
So that's why
So
we
delta
multiply
V.
with percentage. So the value
Mm-hmm.
of V is 53.
Yeah.
So we shift this value over here.
So we multiply. So we're gonna do
Yes.
53 multiplied by percentage of V,
Divided by
divided by
100.
100.
So this will be equal to your final answer. And your final answer will be equals to 53 multiplied by 4 divided by 100. So your answer is
2.1.
2.12, right? So what will be your final answer? Absolute uncertainty.
So is it gonna be 53 plus minus 2.12?
Okay. But what will be the value of delta V first? Because we need to finalize the
Oh,
error also.
okay. For delta V.
So basically, the main thing is your answer is 2.12. The problem is with that significant figures, right? So we need to use only one significant figure, right?
So 2.1 only? Because we like round it?
Mhm. We just round it off to 2 only because only one significant figure. If we write 2.1, so there are two significant, right? So we need
Okay.
to round off
So
till
right
one
now,
significant. Yes.
so it's gonna be 53 plus minus 2.
Yes. So actually it
Okay.
is, right?
Okay, get it.
So that is the
Oh,
concept of one significant figure, because if we don't round it off till one significant figure, so might be we only got 1 mark over here, right? It depends upon the situation. Might be you got 2 also, if they just ignore that mistake, but that is compulsory to follow that procedure, right? Because the purpose of the uncertainty is that to round off the errors, right? Because that is
okay,
the
all right.
meaning of absolute. Absolute means to fix value, not like 15.3%, 10.4%. So if you are getting like this, so those are not absolute errors, right? So they are already in the decimals, so there is no absolute concept over there. So that's why we round off till one significant figure, so we get absolute value over there. Okay.